when you're looking at these here, what you have is 160 degrees. Okay, so if you kind of sketch what you're dealing with, here's my initial side. It's almost to 180 degrees. So it's going to be in which quadrant? 2. Okay, and then my reference angle, I can solve this pretty visually, right? What would I have to do to move from 160 to 180? 20 degrees. Okay, and so that would be my solution. Okay, when I'm looking at it in terms of radians, it's going to be a little bit tougher for most students to kind of see where those fall. But when I look at my denominator, my radians are going to be divided into 180ths. Okay, so what that means is here's 180 over 180. Right? It's 1 pi. Okay, but this one is a little bit less than that. But is it halfway? Halfway is going to be 90 over 180. Is this less than 90 or more than 90? More. So I know it's going to lie somewhere here, right? So once again, I see it's in quadrant 2. Okay, and so for me to be able to figure out how many more 180s do I have to go to get back to this? So again, this one was 180 over 180. What I have right here is 139 over 180. And so if I take that difference, I get my reference angle. So 180 minus 139 is 141. Carry along the pi over the common denominator on here, and that gives you your solution, 41 pi over 180. Okay. The degrees are generally the easier ones. So here's my initial side. I go past 180, but not quite to 270, so I know I'm in quadrant 3. Okay, so what I can do to find the measure of this reference angle is I can take my original angle, 236, subtract that from this portion from here to here, 180 degrees, and that's going to leave this reference angle here. And if I entered this as a calculation, because I see the preview here, it should give me what that number is. So you could just enter 236 minus 180, okay, but that's going to give you 56 for your solution. If you're dealing with radians, again, being able to work with fractional or rational portions of that, I'm still dealing with my same initial side. But here, as I rotate through, I'm in terms of 90ths. So this is 45 over 90 pi. This is 90 over 90 pi. This is 45 plus 90, or 135 over 90. So I can already see here, and then this would be 180 over 90. So I can see here it goes past 90 over 90, but it doesn't quite go to 135. So it's going to be here, once again in quadrant 3. Okay, and so for me to find this reference angle here, I'm going to take my original 109 over 90 pi, and I'm going to subtract what 1 pi would be, which is 90 over 90 pi. And so if I take, and again, you could enter that whole thing in your in this field, and it should give you the correct answer. But if you do the math on this, 109 minus 90 gives you 19 pi over the common denominator of 90. So if we were to kind of sketch what we're looking at here, 325, again, degrees are usually pretty simple. It's past 270, but not quite to 360. So I see this is in quadrant 4. Okay, and my reference angle here is going to be the difference between a full rotation and this portion of the rotation. So if I were to take 360 minus 325, that's going to give me my solution. And when I simplify that, it is 35 degrees. Okay. Again, radians tend to be a little more of a challenge to work with. I have my same initial side. This time I'm in 36. So this is going to be pi is 36 over 36. All the way back again is 72 over 36, double that. And halfway is going to be 18 over 36. And so if you were to work through this, you go from, here's also 0 to 18 to 36. Add 18 to that. You get 54 over 36. And then add another 18 to get back to 72. So you're looking at 65 of these. So here's 18, 36, 54. We go past that to 65. We don't quite reach 72. So here's our angle. We see that it is, again, in quadrant 4. And this reference angle right here is going to be the difference between our 72 pi over 36 minus the original angle itself, 65 pi over 36. And when you work through that, you get 7 pi over 36 as your solution.